Okay, so we saw what is combustion, which is complete and incomplete, when carbon dioxide in a complete reaction is formed and carbon monoxide in an incomplete reaction is formed. We saw what is an addition, and what do you have on that case is that you see only one product as two reactants and one product. So one, and it is happening only when there is double bond or a triple bond present into the hydrocarbon. And now what we will start with is substitution. The substitution reaction, or the third type of reaction, is when a hydrogen atom or a functional group is replaced with a different functional group. Okay, so we always will have two products on this case. I will write it down. Hydrogen atom or a functional group is replaced because it's substituted. So replaced with a different functional group. You always will have two products. Okay, so let's suppose that we have an alkyl halide. So let's suppose that we have C, and then in one of them we have bromine that is reacting with hydroxide. Okay, so what do you see that is happening? This OH minus is going to kick out bromine and take the place of bromine. So you will see as the product, you will see C, and here instead of the Br, you will have OH, so an alcohol, and you will see bromide here as the atom. Okay, or let's suppose that we have something else. Let's say that we have this one, 1, 2, 3, 4, 5, whatever, and then here somewhere we have a chlorine, and this is reacting with OH minus. Always will be under the catalyst that this is happening. So again, what is happening? This functional group is replacing the halide, and then as the new products that we have here is 1, 2, 3, 4, 5. We'll have two products, and then we will have an alcohol and chloride ion. Okay, when we have an alkane, that is reacting, let's suppose that we have a propane and is reacting with chlorine. I'm writing chlorine as a 2 now. Then one of the chlorines will go and kick out the hydrogen, one of the hydrogens that is there, and it can kick out any of them. So you can place the Cl at any place. I'm placing it here, and the rest will be hydrogen, and then the hydrogen that is kicked out will be bonded with chloride and will form the hydrochloric acid. Or let's say that you have, and here you have all hydrogens and are reacting with bromine. And again, this is under some catalysts that is happening. And then one of the bromines will go and replace one hydrogen, say here, and the hydrogen that is kicked out will be bonded with the bromide ion and will form hydrogen bromide. Okay, well, the third type of substitution is when we have benzene. We know benzene has a hexagonal shape, but the double bonds are not set, so therefore it acts more as alkene. So when we have a benzene, then we will see something like this. And we have the ring, and on each of them you have hydrogen, 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 and this is reacting, let's say, with hydrogen fluoride, and again this will be under some catalyst, and usually is a UV catalyst that is happening. So what it is happening here, if we rewrite the hydrogen fluoride as HF, then the fluorine here will kick out one of the hydrogen, and then what you will see is the benzene with one fluorine here, and you will see hydrogen gas produced. Or if you have the benzene it's too big, but it's fine, and acting with, so let's say, iodine, again will be under the presence of some catalysts, then this, consider it as I, and we'll take one of the iodide ion will take the place of hydrogen, so you will see something like this, and the hydrogen that is replaced will be bonded with iodine to form Hi. Okay, so this is what it is in terms of the substitution, and now we'll move to elimination. So first one was combustion, second one was addition, third one was substitution. Now the fourth type of reaction that we will see in organics is that is known as the elimination. Reaction. And elimination reaction, as the word is stating, is as the type is stating it, two groups are eliminated and an alkene is produced. Okay, so the first situation that we will see is when we have an alcohol to start with, and on the case when we have an alcohol that is starting with, what do we see is that we see always two products that are in the reaction. Products. Okay, so now let's suppose that we have a C propanol and under the presence of a catalyst, a very strong sulfuric acid, you will see that this group is eliminated and an alkene will be produced. So what is an alkene that is produced when we have a propanol? Remember what we said, that alkene has a double bond. So now what we will do is we will eliminate two groups. So this is what it is. Elimination is eliminate two groups. Okay, and an alkene is produced. Okay, so now in order to eliminate two groups, we'll eliminate this OH hydroxyl group and an H, two groups. So now what is happening, you are freeing up those two bonds, okay? And those two bonds are here, but they don't want to be as you see them. So then what do? They combine together and form a double bond here. And on this case, an alkene is produced because an alkene is double bond. So what you will see on that case will be something like this: carbon, carbon, double bond, carbon, and then two hydrogens will be here, and then one hydrogen here, and three hydrogen here. Okay, but don't forget that when hydrogen and hydroxyl group is released, is eliminated from the reactant, then water is produced. So here you go, we have an alkene and a water, two products that are formed. The second type of reaction in the elimination is when we have an alkyl halide. So alcohol is the first one, and when we have a halide, what do you see on that case is actually three products. So let's suppose that we will have an alkyl halides here that is like this. And in one of them, let's say that we have a Br. Okay, and then it is reacting with a strong base. So always this is happening with a strong base, an AOH. So see what is happening now. An A and a Br are hooked together and they are forming sodium bromide, NaBr, okay, which is a salt. But we have to remove two groups. So then what OH will go and grab one of the hydrogens and will form water. And then now what is happening, we still have those two pairs here that of the electrons, two electrons that are freed, but then they don't like to be on their own. They will bond into a bond, creating a double bond between C and between those two C, and then a reorientation of the hydrogens will happen. Will be like this. Okay, so in this case, we will see three products. Okay, so keep in mind that the elimination reaction, when we have an halide, is producing three because we are having an addition of a strong base here, and then the products that are formed are sodium bromide, water, and ethane. Okay, this is in terms of the reaction, and we are pretty much done.